Good morning, good afternoon. This is Belén Gallego. I am part of the MENA CSP Knowledge and Innovation Program, which is a World Bank program that focuses on increasing know-how, innovation, and information, I suppose, in the Middle East region about concentrated solar power. And we work with different governments and institutions across the region. So we're here today to discuss with three top experts about the Australian market and to understand a little bit what is going on with concentrated solar power in Australia. So before we begin, two things. I'd like you to share your name, who is in the audience, because we speakers really we can't see you. You can see us, but we can't see you. So it's always lovely to see how many people, who are the people, and where they're joining from. So please just share your name and your location. And I will ask our speakers to do the same. First of all, I'd like to ask Svante to please introduce yourself shortly and also tell us where you're joining from, Svante.
Hello, everybody. This is Svante. I'm joining from Denmark, and I'm from Aalborg CSP, which is active in the development of the Australian market for CSP and CSH.
Thank you very much. Next, I'd like to ask Daniel to introduce yourself and where you're joining from, Daniel.
Hi everybody, my name is Daniel Thompson. I'm joining from Perth in Australia, and I'm representing Solar Reserve. I'm Solar Reserve's Vice President of Development, targeting the Australian market for our proprietary solar thermal technology.
Excellent, thank you very much, Daniel. And last but not least, for sure, Wes, please introduce yourself and where you're joining from.
Hello everybody, my name's Wes Steen. I'm joining you from Newcastle in Australia, over on the East Coast, and I'm the Chief Research Scientist for Solar Technology at CSIRO.
Thank you very much. I mean, I've been possibly about maybe 12 years in the CSP industry, maybe a little bit more, but I think both Svante, Daniel, and Wes have been very long time also in this industry. Believe me, you are the three possible most knowledgeable experts about this market. So the questions, send us your questions through the Q&A box at the bottom. Before I ask Svante, our first speaker, to share his screen, I'd just like to take a couple of minutes to welcome all of the people who are on the other side. We have Rosie from Greece, we have Callum from Queensland in Australia, we have Jerome from Belgium, Said from Sydney. Thank you very much, guys. Keep sharing. And Svante, could you please share your screen and begin your presentation? Once he does that, just to let you know, this is how it's going to go. We're recording the session. We will send you both the session and also the presentations, okay, after the event. And you can send the questions through the box at the bottom. We will have 3 presentations followed by the questions. So Svante, if you're ready, just unmute your microphone. We can see your presentation perfectly.
All right, good morning and good afternoon and evening, everybody. Thank you, Belén. I'll just quickly jump into this and give you the short story about our past and also what we see in the future for the Australian market. And of course, here in the front page. So again, always I start with why solar energy, Australian experiences, and then looking at CHH, heating or combined solution for Australia, and then also for the CSP or power critical components. And then Aalborg CSP as a company is an integrator in solar and energy solutions, and we work with many different technologies to provide the lowest cost of energy. So first of all, again, introductory slide. I just love the slide. Why are we doing this? Well, because this is the number of solar resources in the world in the lower corner, or the fossil fuel resources in the world: coal, oil, uranium, and gas. And then the big yellow box is the solar energy received per year. So the only thing we need to find out is how to capture, store, and use that, distribute that energy, as we will see many solutions and good things from Wes and Daniel on later today as well. Same picture with a different. Why are we doing this? Well, because if we put CSP in that little square mark, we would cover the world's electricity demands with a bit of a transmission challenge. But again, we don't need to put everything in one spot. So just shortly on Aalborg. Aalborg is a company focused with a similar mission and vision as many other companies in the solar industry. we really just focus on lowering the energy by making more competitive energy solutions. So jumping from introduction to just again, what about our company? Well, we are special in the sense that we have different patents and technologies which are key to creating more competitive solutions, but otherwise we focus a lot on industrial solar solutions and energy storage technologies, which allows to not only think about electricity, while we also serve the electricity market and are happy suppliers of high quality components for Daniel's projects, which we'll see later on. Coming into Australia and looking at Australia, what's really interesting is the focus I think that we have, other than the power projects which is being developed, is what we call integrated energy system, district heating, and industrial solar boilers. These are technology platforms which we have developed and deployed commercially, both in Australia and in Denmark and Europe, which are ready, for market growth. And I would say the next step is that we establish together with clients and governments the required financing structures, because it's smaller scale and it's a different setup than when we look at large scale infrastructure financing. So that would be again also a discussion point. If some of you have some thoughts on that, would be interesting to follow up on that after the talks here. So again, with the past, well, we have a beautiful, excellent project. It was put up in 2000, or signed the contract in 2014, and we completed the construction in 2016. And it's in Port Augusta. It's actually very close to the site which Solar Reserve is focusing on, and we have a lot of good experience, which we are happy to share with you guys, and also have been in discussion with you on several occasions on this. The funny thing about this project and how it's financed is that it's financed based on a tomato purchase agreement. So we have a customer demand for tomatoes from Coles, which are buying these from our client Sundrup Farms, and Sundrup Farms needs heat, electricity, and fresh water in order to produce the requirements for those tomatoes. And so looking at the site, excellent solar resources, and again this map just shows that Australia is the place to be if we want to create a very good and feasible projects for solar energy, given the infrastructure issues in Australia and given the very high DNI. Again, from idea to reality, it took 22 months, and we finished full commissioning and operational on time on October 16th. And if we look at the concept of the system, which I think is very important from a technical point of view in this, the point here is, well, we have on the left side here, it's a tower solution, and it is selected as a tower solution because of the way that the client's demand is, because this is an off-grid project. So there's no grid connection. We're not allowed to export any energy out of the system. So that means that we have to define the entire system design based on the client requirements. And here, solar energy reflecting onto mirrors, creating steam. It's a steam receiver. Why it's a steam receiver? Because we don't need a high efficiency. Other projects will look at molten salt to get a high efficiency on the turbine. We have a very poor, very cheap turbine. It's only running at efficiency of 15%, but that doesn't matter because the exhaust energy is not wasted. That is converted into either a heating revenue stream or a desalination revenue stream, where we're taking water up from the Spencer Bay and into the desalination unit, and then into the freshwater storage. And then looking at the world, the demand here. So let's see if this works. So here you can see the finished project. We have our ponds, freshwater ponds, all the seawater, freshwater brine discharge, which is needed for a desalination system. We have the greenhouse, which is 8 meters high, 200,000 square meters. Here we have the solar field. It's around 51,000 square meters. And the height of the tower is 127. So it's an industrial scale plant, but it's built on commercial terms without any subsidies. So that's a quite interesting achievement for one of the first for the first commercial plant here, or size plant in Australia. And the tanks, there's a hot water tank and for high temperature and low temperature, which is used for storing energy for the desalination unit and for the heating. End products going directly out, being picked up by Coles and put out throughout the Australian consumer market. Now, see if this works here. Yes, here. So again, just a summary. So again, here we created an energy system. We designed an energy system which had the purpose of doing something very different to a normal CSP plant. It had to produce 20 gigawatt or 20,000 megawatt hours of heat every year. It had to produce 250,000 cubic meters of fresh water for irrigation, and then around 1.7 gigawatt hours of electricity without any grid connections. And the outcome for the client here is that they can produce 17 million kilos of tomatoes per year, and a very impressive landmark projects. And again, performance-wise, I would say during the first year of operation, our performance was almost 10% more energy produced than we had anticipated. So a very successful and a very high-performing plant, which is very important, I would say, for our industry, to ensure good references, good stories, so that we can attract financing and clients. So let me just check my time here. Yeah. Still got some time. So if we look at the next steps for Australia, so again, but also the solar solution is solar tower solution is still an option. But again, we can see that also parabolic trough solutions are very relevant. And here again, this is another example of an industrial combined with power. So this is a combined heat and power CSP plant, which we built in Denmark. It's only 16.6 megawatt thermal. Again, small aperture area, only 27,000 approximately. If we look at the concept here, again, we are looking at doing something different. Wow, something happened here which wasn't intended. So here, and here sorry for the Danish language, I just shortly explained. So this is combined where we have hybrid from an energy capture one. We have the CSP trough heating up oil. We also have a biomass boiler based on wood chip, which also heat up oil. Both of these, co-generate, so we don't need storage because we have a big wood chip storage. And then we have the ORC turbine, which is organic ranking cycle, which then operates based on the hot oil as the medium. We're running at much lower temperatures. And again, why are we doing that? Because we can afford a lower efficiency of the turbine than a normal CSP power plant, because we use the leftover heat for district heating. And again, I'm not sure we can see the video here full, but you can see it on our webpage. I'll just quickly jump this to keep the timeline. But very lean, very fast. And what we're doing is we're making modular development of the troughs and partnerships with a lot of suppliers to make sure that we can achieve a lower cost. Because again, the only thing that drives and can drive growth in this business is that we lower the cost, which we also see is happening in a lot of places. And this is also for the industrial area. So, only very shortly, to use the last 1 minute, in the power plant, which leading up to Daniel's presentation, again, what we see is that one of the major issues that we can solve, and we can solve for Australia, but also the rest of the world, is that one of the most often plants errors or failures is the leakages, which is seen within the first 2 to 5 years of the heat exchangers and the steam generators. And here we basically have a solution which has been operating in the market for 10 years with no leakages. And you can see here several examples. I don't know if it's fully public, but maybe Daniel can confirm. But at least in Tonopah, we received news that there's also issues with this Tema type YouTube heat exchangers. And again, all Tema type suppliers has issues because it's fatigue issues, and it cannot be handled. However, We've now used header coil technology, which we are hoping to also use for Daniel's plant in Aurora, which basically have had no leakages for the last 10 years, and thereby increased performance. It lowers O&M cost, and both of these contribute to a lower LCOE, which is exactly what everybody is requesting in this market. So, trying to keep it very fast and lean, I will send the pitch back to you, Belen, and then on to Daniel. Remember to unmute yourself, Belen.
Thank you very much. Send it to us and we will make sure that everybody gets a copy. All right. If you can stop sharing at the top of the screen, please. And the good stuff is you've got, all of their email addresses also in the presentation. Right. I'll ask Daniel now to share his screen. And unmute your microphone when you can for the next presentation. And remember to share your questions through the Q&A box. We have had one about how much the kilo of tomatoes is, but I don't think that is within our CSP expertise at this point. Right, you ready? Perfect. I have to say, Svante, those are some of my favorite videos in CSP. They're so lovely, your videos of the tower. All right, here we are.
Okay, well, again, good morning, good afternoon, good evening, wherever you are. It's great to be here today to present on solar reserves technology as well as what we're up to in Australia. I've only got about 10 or 12 minutes, so I'll skip through it pretty quickly.
Get closer to your microphone, please, Daniel, just a little bit so that we can hear you more clearly. Thank you.
Maybe I'll talk a little louder, that might help. So in terms of what I want to cover off today, I'll touch on a little bit about solar reserve and the business, how our technology is different in the market. I'll touch on Crescent Dunes, our flagship project in Nevada, but then I really want to get into the Australian CSP market and the Australian renewable market more generally, and then finish on our Aurora project at Port Augusta. So a little bit about solar reserve. So we are a global solar energy company. We do solar PV as well as solar thermal, but obviously focus mainly on solar thermal because that's where our proprietary technology is. We are active kind of in all the obvious places around the world, headquartered in Santa Monica in California, but larger offices in South Africa as well as Chile. Here in Australia, we have our headquarters in Adelaide, and that's to really spearhead the development of our Aurora project and the projects that follow. So you can see a bit of a flavour of the projects that we're progressing around the world on that map. How our technology works. So we have a very tall tower, and in the case of our Aurora project, it's going to be around 240 metres tall, so quite significant. And we use heliostats around that tower to concentrate the sun onto the top of the tower, onto the receiver. We pump molten salt in its cold state up to the top of the tower, hit with all of that energy from the sun, gets heated up from 288 degrees to 565 degrees Celsius, goes back down the tower in that superheated molten salt state. We then take that through a heat exchanger and create superheated steam. That superheated steam is then used to power an off-the-shelf industrial steam turbine, and then we can provide electricity to the grid. Similarly, we recycle the steam back to water, and then that process is repeated. And similarly with the molten salt, once the temperature is taken to that, we take it back into the cold tank. So importantly, we decouple how we collect energy from how we generate electricity, and that means that we can provide fully dispatchable electricity to the grid. So if we look at this is a typical PV profile. Obviously, as the clouds come over, we start to lose output during the day, and obviously by the end of the day, it's not possible to create electricity anymore. So I think people would be pretty familiar with that sort of curve. With our technology, we're able to provide very much a base load profile, sort of 24/7, or we can provide more of a peaking profile, so more energy, less time, or we can provide more flexible generation, so sort of in between, sort of more of a mid-merit plant, and that can be moved around to wherever the utility or the customer needs electricity. So in the case of our South Australian project, we won't be generating 24 hours a day. The market doesn't need that, but it does need power into the peak period. So we'll be focusing really on those periods. Our project in Nevada, our Crescent Dunes project, we're contracted to provide power normally sort of from lunchtime to midnight each day. Importantly, again, in those after hours when when the sun's gone down and that energy is needed for air conditioning and for lighting homes and whatnot. So a little bit about our Crescent Dunes project. This is our flagship project in Nevada. It's a large facility. You know, it's a 110 megawatt with 10 hours of full load energy storage. We have a 25-year contract with the utility, NV Energy. We won that a number of years ago. This project's now in operation. It came online in 2015, so it's been online for a while, and we have been progressing up the curve to get to full output. But we've had a few teething problems along the way, which have now been ironed out. But very much a significant project in terms of generation. As you can see from this, again, tall tower, 195 metre tower, almost 3 kilometres from one side of the heliostat field to the other, roughly 1.2 million square metres of glass reflecting onto the top of the tower there, so quite substantial. And how that project compares in respect to, I mean, battery storage is always talked about, particularly now when you know, there is a much greater focus on energy storage. But to give you a little bit of a perspective, Crescent Dunes, which is 1,100 megawatt hours, at the time when it was commissioned, was larger than the 300 plus utility scale battery installations in the US, all put together. So it is a very different order of magnitude in terms of energy storage. And I think that will continue to be the case, a big differentiator between solar thermal and sort of battery storage. But I wanted to take you through a few of the slides about kind of actual operation from that facility. And these are 4 kind of images throughout the day, a particular day back in August of this year. And you can see first thing in the morning, the sun comes up, we start to collect energy in the molten salt pretty early in the day, about 7:30 a.m. And then as the day progresses, we start generating electricity, and again that's sort of dictated by the utility. So electricity generation starts coming on about 9:30. Later in the day, about 6:30, we stop collecting energy. The sun's starting to go down, but then very much into the evening, we're still able to generate electricity well after dark, and that's I guess a key to the technology. So here in Australia, I'll touch on the Australian renewable energy market. Now, Australia is an interesting place to do business from a renewable energy perspective. We very much have a federal renewable energy target, and that's, as you can see in that black box at the top, it's 23.5% of renewable energy by 2020. Now, Australia has essentially achieved that already, and we're 2018. So you might say that Australia really doesn't have a target now because we've kind of already ticked that box. So it's really been left to the states to come up with their own targets. And you can see as you sort of move around the map of Australia, it's a bit of a grab bag of targets in different states, ranging from Western Australia, where I'm based, where there's no renewable energy target, to some quite ambitious targets in places like the ACT and Tasmania, and even places like Queensland, Northern Territory, South Australia, which have got a really strong focus on renewable energy. And that, for a developer's point of view, really dictates where best to target in terms of developing projects. But compounding that is that Australia, while it's got a great solar resource, the transmission network doesn't extend into a lot of those really, really good solar resource areas. So you can see on this map, you can see some faint kind of fluoro green lines. It might be a little bit hard to make out, but hopefully you can see them. And the number of locations where they actually push into that red sort of higher solar resource area are sort of pretty few and far between. And you can sort of, I guess, draw a bit of a curve around where some of those locations are. And it won't surprise you that our project in South Australia is in one of those areas. But it does give you a perspective that while we've got an exceptional solar resource in Australia, it's not always in the locations that you can develop projects because the transmission network is not there. So here in Australia, we are developing a project, and it's in a location at Port Augusta, not far from Alberg's project, just down the road. And the reason this project came about was really one driven by the community. And this was the past for Port Augusta. It was a coal power station town, 2 thermal power stations there. And the mayor of Port Augusta was a very, very strong advocate for solar thermal. The community in that location had long suffered health impacts from those power stations, and they recognised they needed to do something else and really look for another technology. and they saw solar thermal as being a great fit for the community. And this gives you a sense of some of the advocacy that community did. You know, you've got a community of 300 people that walked from Port Augusta to Adelaide, about 350 kilometres away, to lobby the government to build solar thermal in the town. You know, countless newspaper articles, surveys they run that really showed the overwhelming support for solar thermal, and that prompted the government, South Australian government, to take their electricity load out to market and tender that out. And fortunately, Solar Reserve was successful in that tender, and we beat some of the incumbent gas generators by being able to offer the lowest price in the market with solar thermal, which is really tremendous. So the facility that we're looking to build in Port Augusta is a project we're calling Aurora. It's a hybrid facility. It's 150 megawatts of solar thermal together with 70 megawatts of PV, and I'll touch on kind of why the PV momentarily. But a few stats there on the facility. So 220 megawatts of combined installed capacity, 1,200 megawatts of storage, around 650 gigawatt hours of electricity generated annually. Huge number of people that will be involved in the project from a construction and operations point of view. You know, we'll peak at more than 1,000 people during the peak construction, averaging about 55 people full-time operation and maintenance, and the predominant majority of workers coming from South Australia. So why solar thermal and solar PV? Well, our facility does have a reasonable parasitic load, specifically when we're collecting energy but not generating it, because we have to obviously move the heliostats around, and we've got pumps and whatnot. So having the solar PV there enables us to really utilise the sun to cover those loads as well, but also enables us to generate more electricity into the peak period of the market. So instead of using some of the electricity during the day, we're able to generate more of that into the times when the sun's not shining, and that's quite important as well. So it is, and obviously it adds a lot of jobs to the facility as well, which is important. I've only got about a minute left, so I'll touch on where the project's up to. So we signed our contract with the South Australian government last August, and since that time we've been very busy in progressing the development. So secured a number of key milestones to date. We have formed an agreement with the local Aboriginal group there to participate in the project, formalised our development approvals. We've set up our Australian offices. We established a partnership with a local mining company to share the transmission infrastructure, which has got a lot of mutual benefits. We've rolled in the solar PV and secured the approvals for that. And we've recently signed a memorandum of understanding with a local South Australian company that we're looking to have construct the heliostat for the project. So we're now towards the back end of 2018. We're expecting to hit financial close early in 2019, and that'll kick off construction. We're looking at about a 30-month build for the facility, and then a 30 to 40-year operating life, supported by the 20-year contract we've got with the South Australian government. So that is my last slide. Certainly welcome questions as we progress through, and yeah, I hope you've enjoyed what I've had to say today. Thank you.
Thank you very much, Daniel. If I can ask you to stop sharing your screen at the top. And then I'm just asked, without further ado, for Wes to share for his presentation. And then we'll take your questions. There's been already one sent through, but please do send more if you have them. And we will answer them thereafter. We should have maybe 5, a little bit longer for the questions. You can make that large.
How's that, Belen?
Perfect. You're ready.
Lovely. Hello, everybody. That's a perfect introduction from Daniel and Svante to what I'd like to talk about. I'd like to talk more about the emerging CSP markets and technologies that might make up the future, particularly in Australia. A little bit about CSIRO first. We're a research organisation, a bit like DLR in Germany, or Sandia in the United States, or the Chinese Academy of Sciences in China. We have over 5,000 people spread over Australia, and we work in all areas of research, from agriculture, health, land and water, food, data, big data, manufacturing, oceans and atmosphere, particularly climate science, mineral resources, and also, of course, energy. Now, it may not come as a surprise to most of you that the energy policy debate in Australia has been going on for quite some time, particularly recently, and it's been quite a huge issue. You could even say that it's unsettled the existing government and has led to some quite extreme debates about where energy should go in Australia. But there are three key policy measures which the government has announced, and the three of them are, first of all, they are committed to meeting the Paris COP21 greenhouse gas targets of 26 to 28% reduction based on the 2005 emissions by 2030. Australia has, probably 10 years ago, Australia was one of the cheapest countries in the world for electricity. We're now one of the world's most expensive, and so that politically has been quite sensitive, and the government is committed to trying to, at the very least, stabilise or perhaps even reduce the cost of electricity and energy more generally in Australia. The third point is the reliability of supply is paramount. We have had blackouts recently, usually due to quite severe storms or weather events. Nonetheless, it's been quite sensitive issue. And what we have done, in fact, it's been so sensitive that the government has coined a phrase that I haven't heard before, fair dinkum energy. It's just come about in the last couple of days. And when quizzed about what that really means, it's about firm, dispatchable power for Australia. And Daniel provided an excellent presentation there about how CSP can provide that firm, dispatchable power, either spread across the day or as a peaker project in the evenings, or perhaps somewhere in between. So in this context, CSP, I think, has great potential in Australia. Another of the areas that's led to policy debate and quite a lot of conjecture about where Australia's energy should go in the future is the retirement of coal-fired power stations. Now, in the past, Australia's been up around the 75% mark of its electricity coming from both brown and black coal-fired power. This graph here, the one on the left, shows a neutral growth scenario, so just a slight rise in electricity production over the next 15 to 18 years. And on the right-hand side, the growth scenario, but with a low growth, so where energy efficiency starts to play a big role and energy growth actually reduces over time. But in both of those graphs, you can see that the brown and the black areas of those columns are reducing significantly, and that's due to the retirement of brown and black coal-fired power stations. We have retired over 6 gigawatts of coal-fired power in the last 5 years. That's 12 coal-fired power stations. And that's out of a total generating fleet of around about 50 gigawatts. So it's had a huge impact, but the impact down the track could be even greater. And we're talking about 15 to 16 gigawatts of coal-fired power being retired over the next 15 years. So that's going to leave a huge hole in the market. It's one of the reasons why the government is so concerned about where dispatchable power is going to come from. And this is really why I think CSP could play such a huge role in the future. The other issue is that in many countries we talk about gas as being the fill-in option or the transitional option, but gas is still very expensive in Australia. So it will play a role, but maybe not as great a role as people think. I'd like to talk a bit about the business case for CSP, and in particular for the thermal storage that it offers. There are two slides here. This particular slide is for 0 hours of storage. It's looking at the net present value of both a CSP with thermal storage project and a PV with battery storage project. on the bottom. And you can see there at the bottom that PVs with 0 hours of battery storage are cost effective now. That's not a surprise, and that's fully in line with what we see in the market today. Whereas on the top graph there, CSP with 0 hours of storage, so it's just CSP with no thermal storage at all, doesn't become cost effective for about 10 years and remains only marginally cost effective into the future after that. So what happens if we start to add 6 hours of storage in? And the green line here shows that in the case of batteries down there on the bottom, the fact that PVs are reducing over time, batteries are reducing over time as well, and we fully expect them to come down to of the order of $150 per kilowatt hour electric over the next 5 to 10 years. Nonetheless, batteries are still a relatively expensive form of storage. And so you see straight away that the PV battery case doesn't become net positive until about 2030, so after more than 10 years. In the case of CSP, though, with 6 hours of thermal storage, it immediately makes the profitability look much more exciting. And in fact, in the next few years, CSP with 6 hours of storage could become cost effective. And even more so with 12 hours of storage. The red line there shows that it's becoming net positive very quickly, whereas in the case with batteries and PVs, the NPV positive story moves further out into the future. A number of studies have been done looking at the national electricity market, which is the part of the grid over in the southern and eastern states of Australia. And Daniel showed before how the electricity grid does not extend very far into these sunny areas. But we modelled 21 of the top load events of the season occurring in the national electricity market and found that CSP with storage, and we're talking about 5 hours of storage here, could avoid the need for augmenting the grid in 72% of the constrained sites in the national electricity market. On the R&D side, CSIRO has built 2 small research solar towers in Newcastle, a 750 kilowatt hour tower on the left and a 1 megawatt hour tower on the right there. We use this to conduct very high temperature receiver developments for the future of CSP technology. I'll try and get this video to work here. We have relatively small heliostats compared to what's available in the rest of the world. Our heliostats are 5 to 7 square meters each. We concentrate on receivers operating at around 700 degrees C or even greater. Because of that, we need quite small receiver target areas. The apertures in this particular case are only one square meter. And that's the other reason for having small heliostats, that we can then get that concentrated energy into that very small aperture. In this case, we're running a supercritical CO2 receiver at around about 720 degrees Celsius. We see that the future could lie beyond the subcritical steam turbine cycles, which make up all of the CSP power stations in the world today. Here it is a parabolic trough, which makes up something like 70 to 80% of the world's CSP installations today. The molten salt towers, which Daniel has spoken about, are starting to become the technology of choice for the future. And what we see, though, is that the subcritical steam turbines have an efficiency ceiling of around about 40–41%, depending on the temperature. And that is going to limit the amount of cost reduction that we can see into the future. So as a research organisation, we're looking at supercritical CO2 turbines, which are being developed right over the world at the moment. The ramp rate for the development of these turbines has been quite rapid. And we would see that these turbines could start to take the place of typical steam turbines over the next 10 years or so. In this case, we're talking about taking all of the existing molten salt tower, but having a supercritical CO2 turbine instead. And then in future, going up to higher temperatures again, higher temperature storage, and a higher temperature supercritical CO2 cycle, looking at turbine efficiencies then of greater than 50%. One of the reasons we're interested in this supercritical CO2 cycle is that much of Australia's CSP market lies towards the edge of the grid. And there's quite a lot of opportunity for power station sizes around about the 25 to 50 megawatt capacity. Now, steam turbines typically don't like to go much below 50 megawatts. As you can see from this graph, at a 550 degrees turbine inlet temperature, the steam turbine efficiency drops down quite markedly as you get below 50 megawatts. But the supercritical CO2 cycle at 550 degrees retains its efficiency down to around about 10, 20 megawatts, which is a capacity of choice for us. And of course, if we go to 700 degrees turbine inlet temperature down the track, that efficiency curve would jump up to around about 50% or so. So there's a place in the market for supercritical CO2, obviously not right now, but sometime down the track. And we are demonstrating a supercritical CO2 turbine system at CSIRO in Newcastle at the moment. There's a huge program underway in the US at the moment to develop this same sort of system called the Gen 3 projects. And there's also a significant program underway in China. So thank you for your time, and happy to answer any questions.
Thank you very much, Wes. I'm going to ask you if you may just take off. Right, so first, I know that Svante has been answering some questions, so you want to just take those questions. There was a couple of them, one in the chat and one in the Q&A box. Svante, can you just tell us live and give us some information?
Yeah, sure. Hi everybody, thank you for your questions. So I'll just take the last one first. So there was a question related to if concentrated solar towers, have a role for industrial process heat application in Australia, and I would say yes, it can have a role. What we see is that when we do the feasibility studies industrially, and we have a certain combination of the demand where we don't need, say again, or it doesn't make sense to make electrical storage, then you can go for steam receivers, and those are much they have a much cheaper material selections and other things which makes it feasible. And that was the case in the Sundrup Farms case. Basically, that project with the tower was selected out of 4 combinations, where 2 were with parabolic trough and 2 were with tower, where there was a comparable analysis about the cost efficiency of the projects and the capex levels. That would be the question for this. That the next question was on the Q&A session. And just reading up, if you haven't seen it, question was e-solar heliostats were used for Sundrup Farms. How was the cost effectiveness of their design, and does their failure greatly impact the CSP industry? And well, first of all, on e-solar, it's correct. E-solar unfortunately did not make it through the lack of projects which we've seen globally, and lack of orders, and didn't get new financing, so they are not here anymore. The technology is now owned by Aalborg. We have it in the basement just below me here, but it's not deployed, and we're looking for investors who are willing to bring that back into the market. And that is exactly because of your question, because both the modularity and the cost effectiveness of this design and then the performance has greatly achieved our targets and the expectations, which means that at least we have a proven, very competitive solution here, which is scalable both for small scale industrial applications, but also for larger scale applications like Daniel's applications, although there are other considerations which are also sometimes coming into play here in relation to how many heliostats you can control and the shadow effect when you get further distances. But that is a more complex detailed design algorithm that decides this. But definitely, it's I think it's a loss for the industry. There are other suppliers which have say again heliostats available and of course market them for the larger scale project. But Solar Reserve has done their own development of the heliostat. I've talked with Kevin several times on this, and are now partnering with the Australian company, and we really hope that you can get your new design in and prove that out again. The second thing, you know, there are companies in Europe and also in Israel which have, you know, heliostat fields for large scale, but again, I'll say it's not really a commodity to buy a heliostat field. You know, you really need to work with partners. It's such an important part of the integration of the solar plant. So from my point of view, of course, I do believe that there are others ready to take over from eSolar. Again, when we left eSolar and when they were bankrupt, the cost level for the erected heliostat field, including all construction and commissioning and foundations, etc., was in the area of $100 to $120 per square meter, and I think there are other players which are also, you know, trying to get to the same cost levels, but it is a challenge for sure.
Thank you very much, Svante. Now I have a question for all of you. I've looked at your presentations. You know, Australia has wonderful DNI, has a need for cheap electricity. We've already seen what the PPA was like for the Solar Reserve plant. How come they're not taking it off our hands? What are the challenges still in terms of developing CSP? Because it all sounds like all of the things are there. It's just I don't understand why we're not building, instead of one or two, we're building hundreds of plants. So I don't know who wants to take that question. It's a bit open, you know, but it's about the challenges that are now. Are there financial challenges? What are they exactly? Is it because the technology has been proven and we've all discussed this? So
yeah,
I'd like to hear from you.
I'll take first round of that. So as I sort of touched on in my presentation, Australia does have a federal renewable energy target, and that means there's an obligation on the electricity retailers within the country to procure a certain amount of renewable energy. So it's been very much a race to the bottom for those retailers about how to collect those renewable energy certificates at the lowest possible price. And that's meant wind, and it's meant solar PV. Solar thermal is at a higher price point, but it adds it's got a very, very different value proposition to the market. Now that value proposition hasn't been, I guess, you know, taken into account by the retailers today. It's really been about generating and collecting the certificates at the lowest possible price. And one of the criticisms that we've certainly levelled on the current renewable energy program that Australia has is that all renewable energy certificates are created equal. So if you're a wind farm that's generating electricity at 2 a.m. in the morning when the grid actually doesn't really need it, you're still eligible for one renewable energy certificate for every megawatt hour, versus a facility that's generating electricity at 7 p.m. at night when there's a huge demand, they get the same amount of credit. So we've certainly lobbied for there to be a time of day multiplier on those certificates, as we see in other markets, to really encourage renewable energy at the right time of the day. And I think that's one part of it. There hasn't been a need for those retailers to really look at the time of day of that renewable energy, because I think that if there was, projects and technologies like solar thermal would have a much greater sort of leg up in the market. But we've looked at it in a different way and really been promoting the broader benefits of solar thermal to our customers around the job creation, around the dispatchability, and that resonates with groups like governments that really value job creation in their state. They value that broader benefit to energy security and power reliability that is generally a socialised cost anyway. So I think that's the reason that historically hasn't been as successful. But I think moving forward, as the penetration of renewables increases, there's going to be a much greater role for dispatchability and energy storage. And I think that's where solar thermal with storage is going to have a real role to play.
So essentially, we're creating a market for something that wasn't really structured to fit, essentially. That is always hard to do. I don't know if Wes or Svante, you have anything to add? Otherwise, we can move on.
Yeah, I've been very frustrated for many years. We've had a lot of false starts. Part of the issue, I think, has been that significant coal-fired resource base that we've had for so long. Now, as I pointed out, with that retirement of so many of those coal-fired stations, I think there's going to be an opportunity for something with reliability, with dispatchability, to fill that hole over the next 5 to 10 years in particular. I think CSP is well placed to do that.
Yeah, I mean, changing the way people think about a market, especially if there is no specific responsibility, but it falls across a lot of people, is always hard. And this is definitely something that makes a technology harder to sell, and it takes a lot longer. And the problem is, then you run into issues of people making, like latching onto little things that happened 10 years ago and just, forgetting about everything. Look what's happened right now with the storage. Everyone thinks that, battery storage is cheap. It's, it's already here. When we look at your graphs, we know it's not. But that is the perception. What's going to happen in the cycle is when it goes down, then it's going to get tough for them as well. So, okay, there's a question here. How do you see the technology readiness level of phase change material storage in CSP? I don't know who wants to take that question. I'm guessing Wes.
Yeah, someone's been very eagle-eyed and picked up the phase change material storage in one of my slides. So that's, I'm glad people were watching and so attentive. I think that PCM storage, phase change material, is just one possible option. The problem is that if we say that we want to go to higher temperature electricity, everything changes, not just the turbine, not just the receiver, but the storage as well needs to change. And existing molten salts, solar salts, the nitrate-based salts, are not going to be suitable for 700 degrees. There's a few options there. There's some higher temperature salts based on magnesium chloride, for example. There's the possibility of using particles, and there's a possibility of using phase change materials. Of those, I think that PCM are probably the furthest away from commercial reality, and I did use PCM in my slide as one example that could reach 700 degrees C down the track. But I think that in the near term, PCMs or perhaps other solar salts could be the way to go.
Okay, so Svante.
Yeah, I can comment as well. We were involved in several projects on also both phase change storage and other storage types, and I agree with Wes on his priority. But again, this is just there's different challenges in storage as how to put it in, but also how to get it out and have operational stability. And of course, one of the focus, which I really appreciate from Wes' presentation, is the focus on increasing the efficiency of the cycle. Of course, it does have a cost on the other side. But actually, something I wanted to share with the audience here, but also with you, Wes, is that while I think for the longer term run in 3 to 5 years, we will look at those new solutions and materials as they commercialize. But actually, we've had some very interesting development during 2018, where we went into some strategic discussions around steam cycle efficiency of both PT and tower plants with Siemens directly, and also with GE, and also with Chinese turbine manufacturing. And we were running a parallel process to try to optimize that. And we reached, I would say, what we've seen is that the current, way of designing CSP plants is very focused on how the good Spanish people did it 10 years ago. And that means that, for example, on the parabolic trough plants, when we're looking at different delta T's, what can be achieved across storage tanks, what can be achieved of live steam temperatures into turbine, we were able to increase the live steam steam temperature into the parabolic trough turbine by 12 degrees Kelvin. So 12 degrees Kelvin on this, it gives a huge opportunity for performance increase in the already commercialized plants. And in the case of the tower plant, we were looking again, but here we're operating at a very high steam temperature already and very high pressure, around 170. So it's almost supercritical. So here we're not only able to achieve 1.5 to 2% improvement, but that means that we are again above 45% efficiency on the tower plants, for example, with the molten salts, and on the already commercialized plant. And here. These benefits can only be achieved in partnerships where you have, again, like Daniel and Solar Reserve goes into partnerships with different parties to achieve the optimization benefits, which can be done during the development phase. Well, here, at least we've seen that our cooperation here with turbine suppliers actually enables us to get some really unprecedented savings or performance increases, which can be captured already now. So if you want to talk more about that, let me know, and we'll share some data on that for your studies.
Yeah, even I need to talk to you then, because we have more ideas for more webinars we can do. Okay, we don't have a lot of time, so I'll just like to close with, we had a really interesting webinar on concentrated solar heating for the mining industry, and we had people from Chile and from Australia. And there's 2 facts that I learned and that I think everybody should know, which is why I'm telling you guys. One is the mining industry in Australia uses 5 times more energy intensive than the one in Chile. And the one in Chile is already energy intensive by itself. And if you were to take out the mining industry in Australia, they would consume as much energy as Spain does. So that is quite a lot of energy. In our webinar, we learned that actually combined heat and power is one of the things that, sort of mining companies are looking at and interested in. So I think there is also a lot to be done in that department. There is a lot of energy we're talking about. So I just wanted to put this point there. And without further ado, since we've run out of time, I'd like to thank our panelists. Thank you very much, Svante, for your time. Thank you very much, Daniel, and thank you very much, Wes, for sharing with us. And thank you very much to all of the audience. This was a MENA CSP Knowledge and Innovation Program webinar, and we are actually inviting you now to attend also our webinar on South Africa later on in a couple of weeks. Thank you very much for your time, and see you next time. Bye.
Thank you. Bye.
Bye.